welcome back to another video with Royalsoft Civil. In the last video for structural analysis series, I did an example on load distribution. Load distribution, which was a one-way slab. But in this video, I want to do an example of load distribution that is two-way slab, so you have an idea of how it is and what should you do. Okay, I can even show you the example from last one. So this was part of my last example, which was one-way slab, and this was the question. The question said the steel framework is used to support the reinforced stone concrete slab that is used for an office. The slab is 200 millimeter thick. Sketch the loading that acts along the members BE and FED. A is equal to 2 meter and B is equal to 5 meters. So we said in the last video that if B over A is greater than or equal to 2, it's one-way slab, and if B over A is less than or equal to 2, it's two-way slab. So in this question, everything is the same except that B and A changes. Okay, so in this problem, A, we have 3 meter, and B, we have 4 meter. Okay, so B over A equals to 4 or 3, which equals to, let's do 4 over 3, (1.3), which is less than 2, meaning it's two-way slab, right? Okay, so the procedure is pretty much the same. We need to find the tributary length. So again, the tributary length, we have this BT, as I mentioned, for the middle portion, it's distributed half on each side. However, if it was like AE, like for example, if it was AE, it was only one part, not both parts, because there is no other side. Okay, so and A right here was how much? 3 meter. 3 meter. So 1.5 and 1.5, the tributary length equals to 3 meter. Okay, so now we need to do the same thing. Since it was 200 millimeter thick reinforced stone, we do for the dead load from the table again. Exactly same from the other one. For office building, dead load is 23.6, and we need to multiply by the thickness, which is 0.2 meter, and by the tributary length, 3 meter, and this gives us 14.16 kilonewton per meter. Okay, now we need to do the live load. And the live load again is the same, 2.4, but this time we have to multiply by the new tributary length, which is 3 meter, and this gives us 2.4 times 3, 2.4 times 3 gives us 7.2, so 7.2, okay, 7.2 kilonewton per meter. Now we have to find the total load, which is dead load plus live load, which equals to 14.16 plus 7.2, giving us 21.36 kilonewton per meter. The thing that changes right here, we still draw the same. We still draw a beam for BE. We still draw a pin and roller, but this time we can see 3 and 3, right? And right here B was 4 meter, right? On this one it was just like this, right? When you imagining the distributed load and B, it was like this, right? But on this one it changes. So you draw two lines like this, connect them, and this is always the same if the distances are like this. So you see on BE, let me draw it better. So well, this was like this. Let me draw it on the other side. So like this. So when you're looking, the loading is trapezoidal. So right here, you draw the load trapezoidal. Like this. Right? And this is 21.36 kilonewton per meter. Okay? So from right here to here is 1 meter, 1.5 meter, and 1.5 meter. Now we need to find the By and we need to find Ey. Okay? So for By and Ey, we can use the sum of the moment, and I will not do it because this is basic static. I'll just tell you the answer. So for By, we get 26.7, and for Ey, since it's symmetric loading, we get the same, 26.7. Now we have to draw the free body for FED. So for FED, right here you can see it like this. FED. So similarly, you draw a beam again with a pin and roller. FED. And okay, and you draw downward load. And what are these? So similar to the previous one, right here at E, we have this 26.7. However, these we need to determine the height of these, and for this one we need to do an extra step. How to find it? So we know that 23, we already calculated that this equal to 7.2, right? Okay. Now for half of the tributary length we have to calculate another one. So for live load, for office, from the table, as I said, we know that it's equals to 2.4 the live load, and then half of the tributary length is 1.5. This equals to 3.6 kilonewton, and we add this 3.6 to 7.2, similar to how we did it before, and we get 10.68, and this 10.68 is our new height for right here. So the process is the same, but this time is a two-way slab, and then you need to do one more step, which is doing half of the tributary length, and the load is trapezoidal for this one. If you have any questions, please comment below and I'll answer. And you can also watch my other videos on structural analysis and in the link above. And thank you so much for watching this video.